Good morning, all. I'm Jayashree Karnam. I'm the engineering manager at John Deere. I have been with the company for more than 10 years and have had an opportunity to work with different groups within the company. I started with the Intelligent Solutions Group and then moved to Global Security, and I'm currently with Digital Aftermarket and Customer Support team. My teams and I are responsible to develop and deliver proactive solutions end-to-end. We specialize in distributed computing and cloud computing. That's what we'll talk to you about our journey of realizing value of data. With me, I have our product manager, Jeremy Goebel.
Good morning. My name is Jeremy Goebel, and I'm the manager of our Aftermarket Enablement Solutions team. And my responsibilities include digital product management for some of our John Deere connected support tools, which really is us using telematics and data to drive action towards our dealers to take care of customers. The other part of my job is I lead the strategy for John Deere Connected Support. And so this morning, I'm gonna take a few minutes to talk about our strategy and some of the technology and business value that it creates for our customers. And then Jayashree will jump in and get into the technical details of that. So with that, let's get started. So first of all, when we talk about John Deere and John Deere Connected Support, when we talk to our customers, it's really all about the technology and support that keeps our customers connected to what counts. And our customers range from large construction equipment customers to farmers. And within that realm, really what we're trying to do is delivering the tools to both customers and dealers to keep them operating all the time and keeping them up and running. So as we've done our research across the industry over the last several years, doesn't matter what the customer size is, they all want the same thing. They want a machine that's ready to work when they are. And that is really what we're gonna talk to you about today, is how we're using data that's telematically enabled. We're transforming it into action and then driving the insights to our dealers and customers to take action. And when we look at our production customers, whether it be construction or ag, what we see is when a machine goes down, really it's about a $400 to $2,000 per hour cost impact for our customers. So if you think about it, if you have an operation that relies on a combine and 2 or 3 tractors that are moving grain, if one of those tractors go down, I have 3 machines down costing me almost $2,000 per hour. And that's just the time it takes to get it back up and running. So one of the solutions that we've brought to market, and we started this in 2017, is what we call expert alerts. And Ganesh Jairam talked a little bit about this in his keynote, but essentially at John Deere, all of our equipment that we produce and manufacture from our large and construction equipment is telematically connected for life. So if you buy a new piece of John Deere equipment today, telematics is connected for life as long as the modem still transmits the data. Today, we bring that in the cloud, and Jayashree will talk a little bit more about that. It's then available for our data scientists to do analysis and understand trends and identify failure modes. Once we identify the trends and failure modes, we then put it in our production rules engine, and we process that. And once we identify a machine with an issue, we package it with a solution, and we send it off to the dealer for action. And the reason we do that is our dealer is the person that has sold the product to the customer, and they're the ones that are the primary responsibility. We as a manufacturer do not do any direct support. So that's kind of the relationship we have there. And ultimately that results in customers being served better. So to walk you through this, here's how a traditional repair would work. A machine would have a problem, similar to if you have a car problem. The customer would call the dealer would probably dispatch a technician. Maybe it takes an hour for them to diagnose what's going wrong. But then they don't have the parts. They don't have what they need to fix it. So they have to go back to the dealership. So they're driving back and forth. And by the time they actually fix the machine, it's about 4 hours later. Well, now introduce expert alerts. Machine now is telling the dealer it has a problem. The dealer dispatches the technician with the right parts, the right information, and we go to repair the machine. Whoops. And so ultimately what we see is a really different transformation of how a machine is fixed and cared for in the field. So when we get to the value proposition, really we really look at this as a win-win-win. For our customers, it's a win because they are assured of uptime through their dealer organization and our company. For our channel, it's all about technician efficiency. In our business, the service technician field, we do not have enough people to do the work. And so if I can get a technician to do repair in less time, I can have that same technician take care of more customers, which ultimately is efficiency for our dealership. And for John Deere, it's all about retaining our customers. So what we are on is a journey from being a very reactive, traditional service organization to a proactive organization who's trying to preempt and predict the failures of our equipment. So with that, I'm going to turn it over to Jay Shree, who's going to talk about our transformation through technology.
Thanks. Thanks, Jeremy, for setting the stage with the business problem that we are trying to solve here. As we look at some of these capabilities, let us think through what it takes to accomplish a goal like that. So we need data. We need more data that is coming near real time, and we want this data to be of good quality. So let me reflect back and talk about my personal experiences in this journey. I was part of the data platform when JD Link originally went live in 2011. We did all the standard process of software testing, performance testing in readiness of go live. And the night we went live, the volume of data that came into our system challenged us. It challenged our processes, it challenged our architecture. We had to react rapidly. Many long sleepless nights have been spent by many teams to figure out how to deal with this growing volume data. We are also talking about the velocity of data. If you talk to data scientists, they'll tell the older the data is, the less valuable it is going to be. How are we going to solve that problem? Now, what is the use of a data which we have, but it is not of the highest quality? If you start receiving nulls in the data, or if the data is truncated, or if the data is inaccurate, it loses its value. Let's talk about the journey of how John Deere has covered this trajectory and reflect on some of the architectural challenges that we have overcome. In 2011, when JD Link first went live, we were on a monolithic architecture. We were on-premise, and I mentioned to you the data actually overwhelmed us at that point in time. If you look at the graph below, it is very insignificant compared to what we are receiving today. However, to deal with the growing volume of data, we did vertical scaling. We started trying with bigger database. That didn't help us. We pivoted to node architecture, tried to do horizontal scale. That worked for some time, but not long enough. And that is where some of the advancements in the cloud technologies really helped us. The elasticity feature of the cloud is most applicable and relevant when we want to experiment with this kind of growing data volume. Little bit about how this works. John Deere has hundreds of sensors installed on that. And we have config authors who are constantly defining what kind of data to collect. Do you want to know what is the speed of the machine as it runs? Do you want to know oil temperature? Do you want to know coolant temperature? All these different parameters is being defined as a part of configuration that gets pushed to our equipment. So as our equipment runs, it collects the data and transmits over the air, either using the cellular connection or satellite connection. In 2011, we used to get this data once per day, once in every 24 hours at night. In 2017, we started our expert alerts journey, and we started very humbly there. It started with more of if-then-else kind of conditions. If I get this kind of diagnostic trouble code, I would like to take this action. If not, I'll take the other action. However, in 2020, I mentioned to you our data scientists needed more data and more faster data. That became possible. We started receiving this data at a frequency of once every hour. And that challenged our architecture again. So now I'm talking about the expert alert product architecture. So when we started, we were in cloud. We had some lessons learned, but we were taking care of the provisioning aspect. We were managing the service. Our teams would decide how many instances we need, how many EC2 we need, and when. So there is an element of seasonality to John Deere business, especially when you look at the ag business. There is a planting season and there is a harvesting season, which is when most of our machines run. And the volume of data that comes in at this point is huge. So our teams used to spend a lot of time keeping the headlights on, making sure the product is running. But in 2020, when we had the growth in the connected machines and then this growing volume of data that is coming fast, it really challenged us. We had to take a step back and figure out, how do we deal with this? What kind of architecture we need in place to support these capabilities? And that is where the Spark capabilities seem to be really very useful, because it is fast, scalable, fault tolerant. And in addition to that, when you complement with serverless computing, so you're taking away the responsibility of managing the infrastructure from our teams. We let the experts, like any of the cloud providers, in our case AWS, deal with how do they support these capabilities like Lambdas and the microservice architecture, and our teams get an opportunity to focus on the value delivery aspect of it. As we look at 2022 and beyond, there is a constant growth in the number of connected machines, and our data scientists want data as it happens. That means near real time or real time. So we have some projects underway that collects data every single second. So that graph you can see that our data volume is constantly growing exponentially. And that is where we are constantly looking at our architecture from the scalability point of view. One other aspect that I would like to add on is the cost aspect. So how do we ensure that we don't increase the cost humongously while we are delivering a solution like this? Keeping an eye on the compute capabilities is going to be very useful and meaningful. Whether you want to use Photon, Graviton, or any other advancement can make a big difference. I'll talk a little bit about the workflow of Expert Alert. We get terabytes of data. I think one way to think about it is we get at least 4 to 5 million records every single day, and this data is ingested and enriched. I have mentioned here partitioned intentionally because when you get this kind of data, how do you make it useful? Who are the ones that are going to use this data first? It's going to be our data scientists. Now think about it. You have a web application to use, and it takes about 3 to 4 minutes for each page to load. How effective is your day going to be? And I think that is precisely how important it is, the strategy of partitioning. Can we partition our data effectively and meaningfully? And can we do some Z-ordering? Can we do some, basically, how do you optimize it in a way that this data is consumable for our data scientists? Once they get this data, they do tremendous amount of exploratory data analysis. And we enable them by doing the feature engineering, making the necessary data elements readily available, whether it is in offline feature store or online feature store. After all this thorough testing, when they are ready, we apply our framework. When I say framework, it is the robustness of our DevSecOps practice that we apply so that it is a production quality solution. At this point, Expert Alert is born. And Expert Alert is a combination of not just problem, but it also includes a recommendation about how to solve this problem, which is what makes it very powerful. Once you have an insight like this, we send it to the interested consumers. We also monitor how is the delivery of these insights. Is it reliable? We collect the feedback from the consumers, and then we do a retro on it. Was this insight useful? Do we have an opportunity to do any tweaks? What can we learn from it and inspect and adapt? The next important topic when you are talking about a production scale system is how are you going to monitor it? I talked about we started our journey with monolithic architecture, and now we are microservice-oriented architecture. Originally, our deployments used to take about 5 to 6 hours, And of course, there was downtime. And now with these architectural choices, our teams can develop and deploy in small increments and without having an impact to one another. But with that comes the challenge of how are you going to monitor these kind of distributed systems. And that is where the observability engineering becomes very important. Developers used to previously write log statements that would help you for troubleshooting. And an advancement to that was getting some metrics to track, is there a problem or is there no problem? But when we talk about a proactive solution, an important aspect to think about is, if a web page that you're using goes down, you get to know about it. You can complain about it. You can call somebody and, hey, what's going on? But when we are dealing with the proactive service, many a times, our end users don't even know that they were supposed to receive an insight. So they never complain, which means the responsibility of the quality of service lane is totally on our engineering teams. And that's where the observability engineering has been very powerful to us, because now we are able to track what is the number of errors, how the functions are performing, what is the latency on the live system as the data is flowing through. In the bottom section, you can see there are some graphs. That is how we are typically receiving our data. And if you can see, there are some spikes. Now, did you build your system for failure? What happens when there are failures like this, or when there are spikes like this? Can the system self-heal and self-recover? Again, these are some of the very fundamental aspects of engineering that are very important, because in the previous architecture, we did not have these capabilities. As a result, our teams used to spend a lot of cycles just monitoring the system to make sure, are we performing as we should or not? And now, whether it is planting season or harvesting season, our teams will tell, I ask this question, how are our systems performing? And they will tell system, if it is not doing well, it will tell us. Because there are thresholds and alerting set up in a way that if there is a deviation to what is expected, the system will let us know. So observability and reliability engineering are going to be very key aspects of distributed systems, like especially as you talk about this kind of high volume data. People are probably very familiar with the graphs, data scientists especially, because you do this kind of activity for a lot of exploratory data analysis. We try to do something similar for an operational data. In this specific example, it is a job that has been running every single hour, and then we are trying to figure out, did we send the expert alerts in a timely manner? If you look at that graph chart there, you'll figure out that the mode of this is pretty good. I mean, from the time an alert got generated, you sent it in less than 30 minutes. But if you take the average, it is about 90 minutes or more. A question to think about is, then how are we doing this? Is that acceptable? Is that not acceptable? And these are, again, some of the very important aspects to think about. How soon you want the data to be sent, and where is this outlier coming from? In some cases, in our business, what happens is there are John Deere equipments that are doing the job in where there is no connectivity. So the machine collects all this data, and then it probably transmits it when it comes into a good connectivity zone. At that point in time, you got the data, but it is old. Is there value in generating an insight and sending it out? So I'm not saying yes or no, but these are very important aspects of the data quality check we have to do. This is an architecture most of you are very familiar with. This is the Delta Lakehouse architecture. I will not go into the details. You have heard the benefits of it a lot from Databricks team. A couple of things that I would like to call out is, we are using this in both batch mode and streaming mode. From the use case implementation point of view, one way to think about it is, if we have expert alerts that are uptime, that are critical in nature, you would want to send them out as quickly as possible. So probably those are typical ones, good use cases to go in the streaming mode. And to think about it from the relevance point of view, there's a machine running in the field, and if that machine keeps repeating, hey, we are getting this DTC diagnostic trouble code 4 times, 5 times, then you probably want to send it out for dealer to take a look at it, and dealer will have an opportunity to have a conversation and talk very precisely about what the problem is, and then probably schedule a maintenance even before the problem happens. However, if you're thinking about the performance optimization, you can probably send once a day, once a week, or maybe during the off-peak season. So those may be a good considerations for the batch use cases. And the choice between whether you go streaming or batch can have an impact on the cost. With respect to ML flow, our teams have been experimenting some of those capabilities, and they are really liking it. There are other flavors of ML implementation that we do have in our enterprise, but some of the announcements that we have heard lately has been pretty exciting. I want to quickly talk about the governance aspect, because you cannot end a conversation about data product without talking about the data governance. Who is using this data and for what purpose? Is the data auditable? Is the data traceable? Are you compliant with GDPR laws? These are all, again, very important aspects as you think about your data product. We have our enterprise data lake team that has set these standards for all the data sets that we follow. And we have over 1,900 data sets. I talked a lot about the expert alert, but probably you're curious, you want to know what a true expert alert means and what it can do. Here is an example of a weld crack. Let me start with the disclaimer there. John Deere builds very high quality machines. But then if you think about the terrain in which they run, the wear and tear that happens, problems do happen. And that is where proactive service is another way of helping solve problems before it affects the customers. In this specific example, it is a ML use case, and we are not using the computer vision ML modeling here. The way it works is we are getting a lot of the measurements, the data points, and those data points are like, what was the load factor at this point in time? What was the engine speed? What was the temperature? I think these are all the variety of measurements that come into our system, and our data scientists who are the expert about how to read this data, look at this data, and derive meaning out of it. Through this expert alert, we were able to reduce more than 80% of the repair cost. If we detect this early, it is very easy to solve the problem. But if the problem like this goes undetected, then you have to kind of replace the frame. So thanks to this expert alert, it helps in reducing the cost by 80%. In addition, reduce the downtime. I talked about the architecture, I talked about the technology here a little bit. But ultimately, when we talk about the success of a data product, it is the people aspect that becomes at most important. In our environment, we have data scientists from all these different production systems, tractors, combines, construction, forestry. If you look at it, these are all pretty different business units, and we have the data scientists from there. We have Jeremy Goebel and his team who interact regularly with end users, and they know what problems our dealers and customers are facing. We have our engineering teams that are capable of actually developing solutions to fix some of the problems that our end users are facing. But the collaboration aspect is very important, and using unified data lakehouse, it has helped us use the data under one common umbrella to serve the higher purpose of being able to provide proactive solution. In addition, one other call out that I would like to make is John Deere has been on this journey of agile operating model for past couple of years, and that has helped bring a lot of transparency into our environment, break silos. We talk about the work in 2-week sprint, and then talk about what teams are focused on now, next, and later. If there are impediments, we openly discuss about it and take them to the resolution. Some of these practices has been a big time enabler in the success of this data product. As I come towards the end, what motivates us every single day is how the intelligence coming from these machines is being collected. We have more than 8 petabytes of data in our environment. The challenges of ingesting the data, they are real challenges. How our business partners, right, Jeremy and team, are constantly figuring out what problems we really want to solve about. The intelligence from our engineering teams in building the scalable, reliable solutions, they all work with a single purpose of generating insight to prevent the machine downtime. As we look at the farming of going forward, it's amazing what connectivity and technology can do in addition with data and AI. We just feel we are truly at the beginning of it, and the opportunities are enormous. Irrespective of where you are in your journey, hope our story inspires you to tackle them and make a leap forward. With that, I will ask Jeremy to take us home with the final outcomes.
As we look at the business results, there's a lot of business results we have for our customers, dealers, and Deere. And really, some of the things we're looking at, especially with the technological change we took over the last year, is really looking at our scalable growth. So if we look at the connected machines since 2018, we've doubled that. And we expect to triple that over the next 4 years from today. So if you look at all the work that Jayshree and her team is doing to enable us to leverage that connected fleet, it's quite significant investments. We right now have 4 times the expert alert algorithms running since 2018, and we only expect that to grow as we grow capabilities. And we're delivering 6 times the alerts that we delivered in 2018. And ultimately, that's leading to customer value and uptime, dealer efficiency, and then for Deere, our satisfied customers. I would also like to just end by saying none of this is dependent on one team. I think Jayshree alluded to it. We've got great product support and engineering teams out with every product that are digging in and understanding the details of their product. Jayshree's engineering team, and then our digital product management team. But also at the end, we've got to deliver that to our dealers, and they take it the last mile. And we've got the best channel in the industry, and we're really happy to present to you today some of the advancements we've made with data and analytics. So with that, we are done with our formal presentation and would open it up for questions.
You can give you the mic right here.
Just curious, on your expert alerts, do you charge your customers to be part of that platform, or your dealers, or is that tied into the machine when they purchase it?
So right now today, in our start of this, we've started it as a delivery to our dealers as they're our main sales force to our customers. We're in the process of then now delivering those same insights to customers. So we're working through that right now. The biggest difference when you deliver technical information to a dealer who expects technical information is it's more clear. So a lot of our advice is given in technical language, so we have to convert some of our language to be more customer friendly.
Do you have a lot of issues with false positives on the alerts that you're trying to give to the customers? And when you have those issues, can you talk about how do you deal with it in general?
Sure. So the exploratory data analysis process that I talked about is very exhaustive. And in order to deal with this kind of false positive situation, that is where our customer support teams become very handy, because as teams are experimenting this, these are the real machines, right? You do want to verify whether the problem truly happened or not. And our teams actually have some pilot dealers. They work with them, figure out, is this problem real or not? So the answer to your question is, those are the real challenges, but team has figured out a way how to tackle that. So once it goes through this exhaustive process of validation, that is when we are ready to open it up more broadly to send it to all dealers.
You guys collect the data from the customer locations. Do you guys see any problem with the data security? What kind of data they want to send it as? Or you guys have full control what you want to collect from the customer locations?
I'm sorry.
I think it is. So if I follow your question, you are asking about, is the data consented or not, and what kind of data we use. Is that, did I follow it correctly?
No, I'm talking from more of a data security aspect. Do you guys have a full control on your machines on collecting the data, or customers have some sort of a control? They control what data they need to send to you guys for assessment?
All the expert alerts that we run is on the consented data. So customer has given us the consent to look at their data and then be able to generate an insight.
Okay, thank you.
What's next after expert alert? What's the next step that you're going to take with it?
So when it comes to what next, I think if you look at the John Deere as a business, right, it's a global organization. So the scaling is the very important aspect. Some of the capabilities that we heard in this summit has been very exciting. I think it is more about how do we scale for more advanced ML and deep learning capabilities.
So from the early failures you had when you first started this project, what were some, what did you learn from the beginning, from all the failures in the beginning?
Sorry, can you repeat the question? Sorry.
So
The speakers here face that way, so I'm having a hard time hearing it.
When the project kicked off, what were some early failures that you learned from?
So probably from a business side, some of the early failures that we had was simply the engagement of the customer in the end. So we started out really slowly, building just a few models. And one of our early failures was simply the fact that customers didn't realize they needed to do something. So like our job of actually going the last mile with the customer sometimes. So you can have a machine that's operating that you don't know anything's wrong with. And you call a customer and you say, hey, we need to address something on your machine. And that's more of a marketing challenge that we dealt with. So as far as the technology challenge, I'd let Jayshree talk a little bit about that.
So we have had plenty of our learning. If I just stay focused in my current role since I took up this job, I think the challenges have been how do you build trust between the people? So how are we able to look at the same data and tell that, yes, I think we have sent 10 expert alerts and it got delivered to the dealer. How do you build that confidence? And especially when you talk about a distributed system, what is the accuracy? What is the guarantee that you are actually able to deliver it? And we have overcome a lot of challenges because these were some of the real challenges from our previous architecture. And we tried to make sure that we implement the lessons learned in the new architecture. And that's where I was reinforcing on the importance of observability and reliability engineering to be baked into a production system solution.
So you talked about having a correlation between the customer and maybe something that happened with their machine. So you're able to see that. Are you taking that data and correlating it with the manufacturing process? And if you are you using that opportunity to innovate and make your machines or your processes better, and how are you doing that?
Yeah, I'll try to address that one. So it's probably, if I look at our total journey of using the data, it actually started by us using it to understand product quality and product reliability. And then we evolved that into now being able to, if we'd known we'd had an issue or we found an issue, we can then alert dealers and customer what they need to address it. And now that we have that, we actually, it's kind of a circle, right? So we kind of work our way through it. And ultimately our goal is to continue to build better products where you really don't need this. The reality is, we want to have a quality product that we minimize the need for the number of expert alerts, but they're very high quality when we have them. So,
time for one quick question.
Do you experience any problems with the feedback piece? So you might be getting high temperatures or something like that, but actually can't ascertain why. So to actually get the label for the next prediction.
Can you repeat the question? We are having hard time.
Yeah, sorry. Do you have any challenges with the feedback piece? So you might be experiencing high temperatures on the asset or for whatever reason, and then you actually need them to do some actual analysis on it. So basically that acts as a label for next prediction.
So I hope I answer your question. I hope I understood your question. Let me know if it is not. I think the feedback aspect is a very critical aspect about completing the loop. Those are some of the things we are actively working on. How do we bring that feedback loop to bake into our machine learning capabilities? And this is where the challenges of data quality become real because you likely are getting feedback, but it is unstructured data. So how do we overcome those challenges of processing unstructured data and making it meaningful to bake into your ML solution?
That's all we have time for today. So thank you so much for the time here today. Super thankful. So yeah, we can wrap it up. Thank you so much.